Conrad Industries, Centralia, Washington, USA, is a name synonymous with pyrolysis. And today we'll show you the results of years of study, research, and development in this field. Webster defines pyrolysis as the chemical decomposition of a material produced by exposure to a high temperature. This process results in a synthetic gas, oil, and carbon residue. Let's meet Bill Conrad of Conrad Industries, who's been highly involved in the research and development of the pyrolysis system you'll be viewing today.
Going into the retort. The product that we are running today is rubber tires chipped to approximately a 2-inch minus size. Over the years, we have pyrolyzed many different feedstocks or products. And as a result of that, we have put together a tremendous data bank of information of values of the oils and gases and the carbons that come from this type of a system. One of the other feedstocks that we have used has been alder sawdust. Alder sawdust, as well as fir, gives a calorific value of approximately 400 to 500 BTU per standard cubic foot. It's a good clean gas that comes from this and free of tars and dirt. Here are shredded magazines and newspapers which produce a 450 BTU value gas. Automobile fluff, which is everything in your car except metal, produced 900 to 1,000 BTU per standard cubic foot. Hazardous waste, paint bottoms, 1,000 BTU per standard cubic foot. PET, plastic, 450 BTU. This is wire insulation from cables, 1,200 BTU per standard cubic foot. And municipal solid waste, 450 to 600 BTU per standard cubic foot. We get 1,000 BTU per standard cubic foot out of these rubber tire chips. Now, to better understand our system, let's follow the rubber tire chip through the clean air pyrolysis system.
Feedstocks such as these tires are loaded into a hopper and then fed to the pyrolysis machine. Feedstocks such as tires can be sized for rotary airlocks that prevent oxygen from getting in the system. These tires could have been used as a hog fuel. Incineration may recover heat energy, but pyrolysis does this and more, as it is both an energy and material recovery process. It is, in fact, a recycling option. In this machine, we're producing 1,000 BTU per standard cubic foot of gas. During the process, the feedstock does not burn and is not touched by flame. Instead, it is surrounded by heat, like a convection oven. This method allows for accountability of material and results in energy and material balances. This is the heat dissipating from 2,000 pounds per hour. You'll notice that it is very clean. Part of the heat is used here in this tumbler to dry the product before entering the retort. In addition to the gas, an oil of 18,500 BTU per pound and carbon black, which has good reinforcing characteristics for use in developing new rubber products, are produced. Each machine is specifically designed for a feedstock. This two-tube machine allows for proper time, temperature, and turbulence of the rubber within the retorts to efficiently decompose the product. Several safety features have been incorporated into this system, including reamers to prevent material blockage and safety valves to handle extraordinary pressure buildup. The furnace creates heat, which expands the retort. This end of the retort is free to move and allow for this expansion. The pyrolysis system sustains itself, utilizing part of the pyrolysis gas produced. Here is the furnace, which is using pyrolysis gas to keep the retort at a desired temperature. That flame is from rubber tire pyrogas. Depending on the feedstock, it's % of the gas produced to maintain temperatures. The The balance of the 1,000 BTU per standard cubic foot of gas is an energy source for boilers, generators, or internal combustion machines. As you look down the retort barrel, you can see the radiant heat. The temperature in there is approximately 1,400 degrees Fahrenheit. Tire carbon is dropped from the lower retort into the water-cooled auger and is conveyed to packaging or storage systems. In this plant, the carbon is conveyed pneumatically to a silo for storage prior to packaging. The carbon is very fine and can be used in the manufacture of new rubber products. Pyrolysis gas exits through a series of piping out of the upper retort and enters a condensing system. Here, cooling, condensing, and demisting take place, and the bulk of the gas is reduced to oils. The oil from this rubber is 18,500 BTU per pound. The oil also has potential for further refining to take out various fractions, such as toluene. Oil is pumped to storage tanks for further handling. The highly sophisticated control system designed and built for this clean air pyrolysis machine monitors from this control panel nearly 50 functions of temperatures, pressures, and flow. Any variance from the norm triggers an alarm and indicator lights. The printer readout is a data acquisition device and continually monitors all systems and is done automatically at intervals or can be done directly by an operator. A 1-ton tire pyrolysis machine such as this produces 2 barrels of oil, 40 therms of gas, and 600 to 650 pounds of carbon black. These are byproducts that can be reused. Pyrolysis is a recycling option not only for tires, but municipal solid waste and numerous other feedstocks considered waste. This Conrad Industries system represents a new era in pyrolysis technology for recovery of waste byproducts, whether they be biomass, hazardous waste, or thermoplastics and rubber, all in a safe, environmentally sound and efficient atmosphere.